In this video, we are going to write the equation of the line in slope-intercept form given 2 points. As a quick review, we need 2 pieces of information to write the equation of the line. One of those pieces of information is the slope, which we represent with the letter M. Another piece of information we need is a point. If that point happens to be the y-intercept, our job is made very easy because we can simply use the slope and the y-intercept to write the equation in the form y equals mx plus b, which is slope-intercept form. On the other hand, if the point is not a y-intercept, but another point on our coordinate grid, then we're going to go to point-slope form, which is y minus y1 equals m times the quantity x minus x1. Today, most of our equations are going to be in this form, point-slope form, as most of our points are not going to be a y-intercept. This procedure is a simple 4-step procedure. Here we have an example where we're going to write the equation of the line that goes through the points 2, 8, and 4, 12. In order to do this, we first need to find the slope. As we recall, the formula for finding the slope is y2 minus y1 over x2 minus x1, where the little subscript of 2 and 1 refer to the 2 different points. We're going to choose 2, 8 as our first point and 4, 12 as our second point. So when we do y2, that's our 12 minus 8, all divided by 4 minus our other x value 2. 12 minus 8 is 4 divided by 2 gives us a slope of 2. In our second step, we want to pick one of the 2 points. You want to choose the point that's easier to work with. Now, easier to work with is different for every student, but usually ones without fractions, or if the signs are the same and if the numbers are smaller, generally are points that are easier to work with. In this case, we're going to go ahead and choose the point 2, 8 as our point. We're then going to use the slope from step 1 and the point from step 2 to write the equation using point-slope form. Point-slope form is y minus y1 equals m times the quantity x minus x1. So we're going to fill in y minus our y value, which is 8, equals our slope, which we calculated to be 2, times x minus our x value, which is also 2. This is an equation of the line, but the directions want us to go to slope-intercept form. Slope-intercept form is when y is all by itself. So we're going to go ahead, our first step is to distribute the 2. So we have y minus 8 equals 2x minus 4, and then we want to go ahead and add the 8 to get y all by itself. Y equals 2x plus 4. This equation is in slope-intercept form. We can also go to standard form. Standard form is in the form ax plus by equals c, where a, b, and c are all integers. In order to do that for this equation, we can simply subtract 2x on both sides. We get negative 2x plus y equals 4. This format is in standard form. Alright, there are 3 examples here in which you are to find the equation of the line in slope-intercept form that passes through the 2 given points. Remember, our first step is to find our slope, second step is to choose a point, third step, write an equation using slope-intercept or point-slope form. After, we're also going to be showing how to use the calculator to check your answer. So at this point, you can pause your video, work through examples 1, 2, and 3, and then have your calculator handy so you can learn how to check your answer on the calculator. Welcome back. So for each of these equations, we've been able to find the slope. In example 1, or problem 1, one of the points they give us is the y-intercept. So we can simply jump to slope-intercept form with y equals our slope of negative 2x, and then our b value plus 5. In example 2, we calculate the slope to be positive 3/4, not negative 3/4. And then we choose one of the points, and it doesn't matter which point you choose. If you choose the point 6, negative 2, then you have the equation y minus a negative 2 gives us plus 2 equals our slope, positive 3/4, times the quantity x minus 6. And then from here we need to convert to slope-intercept form. We're going to distribute the 3/4, so we have y plus 2 equals 3/4 x minus, and 3/4 times 6 is 9/2 when you simplify it. And then we can go ahead and subtract the 2 to get y by itself. But since we're subtracting by a fraction, we're going to convert the 2 to a fraction with the denominator of 2, which is the same thing as minus 4/2. So now we have the equation y equals 3/4 x, and we subtract or combine the numerators, which is minus 13. The denominator stays the same, 2. And that's our equation in slope-intercept form. In example 3, we find our slope to be negative 3/2, and then we can use either point. Let's say we happen to choose this point, negative 3, negative 10. So we have y minus a negative value gives us plus 10 equals our slope, negative 3/2 times the quantity x minus our x value, which becomes x plus 3. And then we need to get y by itself. So we distribute, and we get y plus 10 equals negative 3/2 x minus 9/2. When we subtract the 10, we're going to be going to a value with a denominator of 2. So we convert 10 into a number that's over 2, which is negative 20/2. And now we have y equals negative 3/2 x minus 29/2. This equation seems to be kind of complicated for the 2 points that were given to us. So we can check this on our calculator, and it's a really nice process. So on our calculators, here's a typical TI calculator. You're going to go to the y equals button, and you're going to type in your answer that you got, which is negative, and you want to use the negative underneath the 3. 3 divided by 2x minus, and the calculator knows the fraction 29 divided by 2. It can do the order of operations there. And then we want to take a look at the table of values. The table of values is above this graph button. So we're going to hit second graph, or table of values, and we're checking to see that the point negative 5, negative 7 is in this table. Well, here we see negative 5, negative 7 on the table of values. We also want to check that negative 3 and negative 10 is on this table of values. 2 points make a distinct line. So since these 2 points are in our table, or these 2 points would appear on the line, then we know we have the correct equation. So that's how we can use our calculator to check. Sometimes we're given a graph to write the equation in slope-intercept form. Let's get down. When you're given the graph and you can't easily determine the y-intercept because it doesn't look like an integer value, then we can use the same procedure to write the equation in slope-intercept form. And we should expect some rational slope. Each one of these examples looks like when it crosses the y-axis, it's not an integer value. And so we're going to be finding that we're going to be getting a lot of fractions for our y-intercept. Let's go through one example together, and then you can work through the others on your own. In example 7, we first want to calculate our slope. When we calculate the slope, we're going to just count rise over run. So we rise 4, run 3. Then you want to choose a point to work with. And you want to choose again what would be considered an easier point. In this situation, this point right here, 2, 2, is a nice point because the x and y values are the same, and if you happen to make a mistake in substituting into point-slope form, you'll never know because the values are exactly the same. So we have y minus our y value equals our slope, then x minus our x value, which again is 2. Now we go ahead and convert to slope-intercept form. So we're going to distribute the 4/3. We have y minus 2 equals 4/3 x minus, when we multiply 4/3 times 2, we get 8/3. And then we want to add 2 to both sides. But when we're adding 2, we want to have a denominator of 3, so that's the same thing as adding 6/3. 6/3 is also 2. So we get y equals 4/3 x, and negative 8/3 plus 6/3 gives us minus 2/3. So our y-intercept is some y value between 0 and negative 1. As we look at the graph above, it looks like our y-intercept is some value between 0 and negative 1. So it looks like that's the equation of the line. At this point, if you'd like, you could pause the video and work through problems 8 and 9. Welcome back. So in examples 8 and 9, we get the two equations, y equals negative 1/2 x plus 3/2, and it looks like this is, well, 3/2 is between 1 and 2, and it looks like the y-intercept is somewhere between 1 and 2. And then in the last example, we get y equals 3/2 x minus 5/2, which is somewhere between negative 2 and 3, and it looks like our y-intercept is somewhere between negative 2 and 3. Again, you can check on your calculator. If you go to your calculator and go to y equals and you type in your answer, which is for the last example, we type in 3/2 x minus 5/2, and we can look at the graph and see if the graph seems to match, which it kind of looks like it does because the screen resolution is different. It's going to have a different slant. So we could always double check the table and look for the 2 points that they gave us. We got negative 1, negative 4 on the graph, and negative 1, negative 4 appears on our table. We also have the point 3, 2, and 3, 2 appears on the table. So again, we can check our answers using our calculator. One last skill on this particular set of notes is to write an equation given 2 points and go to standard form. In order to go to standard form, we generally pass through all 3 different forms. We'll go to point-slope, convert it to slope-intercept, and then it goes to standard form. But it naturally just happens that way. So let's take a look at example 4 together, and then you can work on 5 and 6 on your own. In example 4, in order to write an equation of the line, we need 2 pieces of information, the slope and a point. So we're first going to calculate the slope. For the slope, we're going to do y2 minus y1 over x2 minus x1. We get negative 2 over 4, which is the same thing as negative 1/2. Then we choose either point. In this case, we'll choose the first point. We get y minus our y value equals our slope, which we calculated to be negative 1/2, and then x minus our x value, which is 2. In order to go to standard form, we first need to distribute this negative 1/2, and we get y minus 4 equals negative 1/2 x plus 1. Let's combine our like terms, so we'll move the negative 4 over to the other side by adding 4, and we get y equals negative 1/2 x plus 5. Standard form has 2 stipulations. One, that x and y are on the same side, and the other is there's no fractions. We can get rid of fractions by multiplying by the common denominator. In this case, the only denominator is 2, so we're going to multiply this whole thing by 2. So we get 2y equals negative x plus, and then 2 times 5 is 10. We want x and y to be on the same side, so we can go ahead and add x to both sides, and we get x plus 2y equals 10. There we have an equation in standard form given 2 points. This is very easy to check because we can simply substitute in the 2 points and see if we get a true statement. So in the equation we have x plus 2y equals 10. If we want to check the point 2, 4, where there's an x we put in 2, and the y value we're going to choose 4 because it's the part of the point. Here we get 2 plus 8, which is 10, equals 10. So that point works. We can simply check with 6, 2, with our x value being 6, 2 times our y value, which is 2, equals 10. 6 plus 4 is 10. So again, a quick check to make sure that we have the correct form. This concludes the video on writing the equation of the line given 2 points. You have some practice problems that you can work through on the next couple of pages, and then we will check those in class.